Okay, the assignment for me. The teacher gave the class of Ming with these assignments. From Monday to Friday, each student need to bring 3 branches to school. If those 3 branches can form a triangle, then he can have a bonus of 1 point. You were given the length of the branches brought by Ming, and please check how many bonus points Xiaoming can get for this assignment. The inputs will have 5 lines. Each line will have 3 integers, and which represents the length of the branches that Xiaoming brought to school that day. So we will have 5 lines and represent the branches that Xiaoming brought to the class each day from Monday, Tuesday, Wednesday until Friday. Alright? So and each day there will be 3 numbers which are the length of the 3 branches that Xiaoming brought to school that day. Alright, so how do we solve this one? Okay. Score is 0. Alright. Then we are going to do something like this. A, B, C is equal to map and inputs dot split. Then we have to figure out if ABC form a triangle. How do you determine? How do you find out if ABC will form a triangle? Any side will be shorter, or the sum of any 2 sides will be longer than the 3rd side. Alright? But if you do this, then the line will be longer, the code will be longer, because we have to check if A plus C, we have to check 3 things. If A plus B is greater than C, and A plus C is greater than B, and B plus C is greater than A. We have to check everything, alright? And this line will be longer. There's one thing in one built-in function in Python which is very helpful in this case. That is sorted. I believe that we had this one before. Okay, sorted. What does that mean? That means it will sort the 3 numbers from small to bigger, from the smallest to the biggest, which we call it ascending order. That means when we assign them to A, B, C, then A will be the smallest and C will be the largest. So you have the sum of the 2 smaller sides, if that is greater than C, and then it is a triangle. Alright, you don't have to check the others, because you will know for sure that A, B are the smallest sides and C is the largest side, the longest side. Alright, so if you have that information in mind, then checking if the sum of A and B is bigger than C is sufficient to determine if ABC will form a triangle. Alright? If it forms a triangle, then we will add 1 to the score. But this line of these code segments need to be repeated 5 times because there are 5 days. Alright? Then for each day we need to do this code 1 time. We need to do it once each day for the triangle, for the 3 branches, and determine if they form a triangle. Alright? So here we need to put this right here for underscore in range 5. It's that easy, which means this part of the code will be repeated for 5 times. This code segment will be executed 5 times. And after we finish this for loop, then we can simply print out S, which is the answer to this problem then. Alright, isn't this quite an easy problem? Is there any question? If not, we'll keep on the next one. Let's skip this too. Alright. No, don't skip that one, this one. This one is important. So this is the equal difference series. We call it a how do you say that? Mathematical series instead of mathematical series, arithmetic series, or mathematical arithmetic sequence. Alright, this is a arithmetic sequence. You will see the difference between each 2 terms are the same. So the difference between 3 and 5 is 2. I mean, the difference between 5 and 7 is 2. Alright? And then the difference between 7 and 9 is also 2. So that in this case, we said that D is the difference between the terms. We call it a common difference. Alright? And so this is what a arithmetic sequence is. Okay, in Chinese, sometimes we call it a equal difference series or equal difference sequence. And let's get back to the problem. Okay, you'll be given the first term and the last term and the common difference of a arithmetic sequence. You need to put out the whole sequence. You need to print out the whole sequence. For instance, if you have the first term of 1 and the last term of 9 and the common difference of 2, the whole sequence will be 1, 3, 5, 7, 9. Alright, this is the difference. Alright, so how do we do this one then? With the help of range, it is quite easy. Alright, Okay, so this is what we are going to do. We have that a1, which is the first term, an the last term, and the common difference. And map int input dot split. Okay, then this is so annoying. All these repeat on my phone. Okay. So what if I do this? I expand the range of A1 to AN and D. You can, for function range, you can specify a third parameter D. And it will specify a common difference. All right. Let's run it then. Run module. Okay, if you have the first term of 1 and the last term of 9 and the common difference of 2, it was 1, 3, 5, 7. And the last term is missing. Do you see that? The last term is missing. What do we do? Because it doesn't really include AN. If you really want that AN, can we do this? Then again we'll have 192. Yeah, that works, right? However, if you submit this code to this problem like this, and then you'll get a grade of 80. This is already the code, and the grade is only 80. Why is that? Let's get back to the messages. Do you see this one? The first item is 9, the last item is 0, and the common difference is -1. And you should have, so you can even have a minus. Like if we have 9, 0, and -1, you should have all the numbers up to 0. But we only have the number up to 2. So what do? There are two ways of solving this problem. Is that we don't really add 1, we add D. Now if you have 9, 0, and -1, you will see the whole thing, the whole series of 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Alright? And also there's another way of solving this, is that since this range doesn't really include AN, and then we'll simply put an AN at the end of it. Alright? This doesn't include AN. So we'll put the last term at the end. So this is also a way of solving this problem. 9, 0, and -1. You will see that 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right. Any question for this problem?
No.
If not, then let's get to this problem, the strongest chain. I like this problem because this problem is derived from a famous English saying, which is a chain is only as strong as its weakest link. Sometimes this will be another way of saying it, which is a chain is not stronger than its weakest link. And why is that? Because when you pull the end of the string hard enough, the chain will break, and it will break at its weakest link. No matter how strong the other links are, as long as the strength that we use to pull the chain is greater than the strength of its weakest link, and the chain will break at this link. And even though the other links are much stronger, and this chain will still break. Alright? Is there any question? So for now, we have this 2, that means we have 2 chains. We have this 3, 2 chains of this line is 1 chain, and another line, the second line is the second chain. With each chain, the first number is the number of links. For this 3, we have 3 links, and the strengths of the 3 links are 15, 17, and 19. And the second chain has 4 links, which are 43, 37, 28, and 11. Alright? But a chain is only as strong as its weakest link. So if I ask you how strong this chain is, how strong is this chain? You need to find out the smallest number of this line, but not 3, because 3 represents the number of links, not the strength of the link. Alright? So you need to find out the smallest number of these 3, which is 15. And if I ask you what is the strength of the second chain, and then you need to find out the smallest number of these 4, which is 11. Alright? So the strength of the first chain is 15, and the strength of the second chain is 11. And we would like to have the largest chain. Alright? Strongest chain. We would like to have the strongest chain, which is 15 out of 15 and 11. Alright? And for the second example input, we have 4 chains, and the strength of the first one is 9. It's 8, which is the weakest link. Alright? And the strength of the second chain is this 7, and the strength of the third chain is 16, and the strength of the last chain is actually 3. Alright? So which one is the strongest? Is it A, 7, 16, or 3? And the answer is 16. So that's what we want to put out. How do you solve this problem? And this is what we do. So now we have n chains. n is equal to n input. And now we would like to get how do you get the strength of one chain? How? Can we do this? Minimum of map is input dot split. Will this get the strength of one chain? This is going to get the smallest number in from one line, which is represents one chain. But this won't work because if you do this, the smallest number that you will get is not 8. It will give you this 4. So what do we do? If I want to get the smallest number of this 4 is without including this 4. Can we do a slice before we get the minimum? Before we get the minimum, can we do a slice like this? We skip 1 and then slice to the end. Can we do it like this? And the answer is no. Why? Because you are slicing a map. Can you see that? This slice is actually after this map. We input one line and split them into strings and convert all of the strings into integers using map function. And however, subscripts and slices are not applicable on a map object. So this won't work. What do we do? What do we do? We will usually do this. We will usually do this. We will convert this map into a list first before you can actually slice it. And then after we slice it, then we can get the minimum out of it. Okay? Then we can have this strength. This strength is equal to this. This will work. However, there's an easier way of solving this. Alright? What is that easier way? Okay. We know we cannot use the slice over a map object. However, the split function will return a list which is sliceable. You can slice the list returned by the split. Therefore, we can actually slice it right here after the string input from the input is splitted by this function. So we simply move this slicing over here and it will work. We will slice this list of strings before we convert them all into integers, and then we will get the minimum out of it. So this is a shorter and easier way of doing it. Alright? So now we need to get this. This line can get you only the strength of one chain, but we need to get the maximum strength of all the chains. So how do we do that? How do we get the maximum? Can we use the max function? Not in this case. Alright. So if we need to get the max value out of something, and then those values are not inside a list, you won't be able to apply max function on those values, and then this is what we can do. So we will have this strength of the chain, and then we initialize this variable with a very small number, very small number, so small that it is not possible. It is not a possible value of the strength. Like, can the strength of a link, can the strength of a chain be 0? No way. Alright. That means you don't even have to pull it, and it will break itself. Alright? So that's not a chain. The strength of a chain is not possible to be 0. Alright? So we want to be, when you want to get the maximum number, then we will initialize the variable to the smallest possible value, and then we will repeat this for n times, because we have n chains. Then each time we will get one. Each time we will get one. Get the strength of one chain. Then we will examine if this one chain is stronger than the maximum strength that we have known so far. Alright? If this is this, we will use this S to record the maximum strength of the chains. And before we look at all the chains, the biggest the number is actually 0. But if you find someone is larger than this biggest number, then this is what we do. We will record this new biggest number by assigning it to S. Alright? Then at the end of after you exit the loop, after you finish the loop, then simply print out S. That will be the answer of it. Alright? So this is how we get the maximum strength of the chains. First, we assume it to be 0. Alright, assume it to be 0. And then if we find a chain that is stronger than the strongest one, then we record this even stronger one to S. After we examine all the chains, and then this S will be the strongest one. Alright, is there any question? If you don't have any question, then it's already 4 o'clock. There's still one thing that I would like to teach, but we don't have time for it. But that's okay. That's good so far. And this is the last lecture that that I can do in this school so far. And I will miss this class, and I will miss you guys. And happy summer. And try harder to finish all the exercise, and
Okay.
you'll get a better grade. Yes?
Okay, thank you for teaching us, teacher.
Alright, sure, no problem. And have a happy summer without going out. Alright? Don't go out, please. Alright? Any question? If not, and then that will be it for today then.